Introduction to the Fibonacci problem.
The Fibonacci sequence is a popular coding problem and a classic example for learning recursion. Each number in the sequence is the sum of the two before it, starting with 0 and 1. While the definition is simple, calculating larger Fibonacci numbers with basic recursion is inefficient. Let's explore how to make it faster using memoization.
The inefficiency of basic recursion.
A basic recursive solution to Fibonacci recalculates the same values over and over. For example, to compute the fifth Fibonacci number, the function might compute the third number multiple times. This repeated work dramatically increases calculation time, especially for larger numbers. That's where optimization comes in.
What is memoization?
Memoization is a technique that stores the results of expensive function calls. The next time the same input occurs, the function returns the stored result instantly. Applied to Fibonacci, memoization eliminates repeated calculations, improving efficiency from exponential to linear time.
Implementing Fibonacci with memoization.
To solve Fibonacci with memoization in code, use a data structure like a dictionary to save results. First, check if the result for a number already exists. If not, compute it recursively and store the result. In Python, this can be done by passing the dictionary as a parameter or by using built-in decorators.
Example code. Python implementation.
Here's a simple Python example. Define a function that accepts an integer and a memo dictionary. If the number is in the memo, return it. If not, compute the Fibonacci value with recursion, add it to the memo, and return the result. This approach reduces computation time and is easy to adapt to many similar problems.
Conclusion and next steps.
By applying memoization to the Fibonacci problem, you make your code vastly more efficient. This technique is valuable for many recursive problems with overlapping subproblems. Experiment with memoization in your own coding projects to boost performance and deepen your understanding of dynamic programming.